Okay, this video is just to show that without the 1 ohm inductive shunt that I was using, I put everything straight back so that the scope right here is across the 0.25 ohm calibrated current sensing shunt resistor. These are the resistors that I'm using for that. Can't really see it clear enough there, but it's a R. Okay, this resistor is RAI 552. The second line says UT-5, and the third one says 0.25 ohms, 5%. And so that's the resistor that I have right here, and I'm no longer bypassing it. It's not in series with the 1 ohm or anything else. I'm just using that as I have all along in the original circuit. Just to take out any question that the inductance in that 1 ohm shunt is skewing the results or anything else. This is just all this, the scope, all 4 channels are connected identically, except I have the negative here, which is, and the negative of the probe, which is going back to the ground on the battery, and the positive of the probe is on the other side of the shunt towards the source of the MOSFET side. And so with that and the waveform across there, the RMS is going to be a lot lower, of course, and so the tuning changes aren't magnified as much. If you do have some inductance, like the 1 ohm resistor I was showing, you might be able to tune it a little bit better with that because each little change is amplified a lot more in the RMS, whereas the RMS at the little DC shunt like this, or a little straight resistor shunt, non-inductive shunt resistor like that, the changes aren't amplified as much. So I think that the other one might be good for tuning to see more precisely where you're at, but it doesn't change the fact that with the regular shunt, you're still getting the same type of waveforms. As a matter of fact, it's smoothed out a little bit. The battery's at 1273. It's running. This is what the Fluke is showing. 2.7 RMS and positive 20 to 50 millivolts to negative 20 to 50 millivolts. And you can see that, I mean, you really got to see that waveform, there's as much above as below. Okay. Okay, so what I'm going to do is I'm going to boot up the Tektronix, and then I'm going to take a shunt reading right there, and I'm going to crunch the data to see if we still have the negative wattage. And even if it's not negative wattage, it doesn't matter, because with the positive wattage, let's just say you're still producing heat anyway. If the total draw on the battery is less than the heat that can be accounted for, it's over. You know, there's more work being done, and that's the whole point. So anyway, I'll boot the Tektronix up and I'll show the waveform across that shunt there.